Hello YouTube, Gadget Boy here. I survived my cold and I'm back to recording. So what we're going to work on today is a USB data charge cable for my phone that's actually going to last more than a week. I have this terrible tendency to completely ruin my cables by I'm not too sure how I managed to do it. Maybe I pick up the phone and it bends it, or I drop it or pull out the connector too hard or something. I have no idea why it happens, but what happens is the connector on the USB micro B side of things gets bent up a little bit and then stops working entirely. It's terribly frustrating because these cables, they've got a capture market on them, which means that I have to spend what they want to charge for me to get a new cable. So I'm paying $17 to $25 for a reasonably decent cable over at Best Buy, and only to have them fail within a month or two. It's a terribly frustrating thing, and I haven't had much luck with getting Best Buy to honor their warranty on their Insignia brand either, which is a little frustrating. So I decided I'm going to build my own, and I'm going to build it with the concept of this part, which is the USB micro B connector, is going to be for, pardon me, belchy, good lord, what was that from? This part is going to be, for all intents and purposes, disposable. So if it breaks, I'll be able to take it off by way of this connector here. This, of course, won't be a loop. I'm going to nip that off and just utilize these connectors. I'll be able to just disconnect it, build a new one, and clip it back on, and then I've replaced the entire... I've repaired the cable basically for $3 instead of having to replace the entire cable for $17 to $25, like I said before. And the other advantage is I'm going to be using a very high quality cable for the main part of the cable. This is actually microphone cable, so it's meant to stand up to some punishment. You know, it's meant to be bent and flexed and messed around with and beaten up, and you can put microphone cables through quite a lot of abuse, and they don't go bad. So we're going to use that. It's got 4 conductors and a shield, which is what you need for a USB connector. I've got my USB-A connector for plugging into the computer, and I've got my USB micro B connector for plugging into my phone. Now the interesting thing is I'm probably going to just completely discard that part of that connector because I'm going to build my own strain relief for this and make it super low profile in the hopes that it will last longer. So let's go ahead and get started. Now we have to start with this microphone cable, and it's going to be a little interesting to work with because it has, although it has 4 conductors in it, they are colored with 2 white connectors, or 2 white conductors rather, and 2 blue conductors. The reason they do this is because those conductors are twisted around each other, and you actually short them together at the ends of the microphone, both at the signal end and the microphone end, and that prevents any sort of capacitive coupling across the wires, because any capacitive coupling that does start to build up gets canceled out by the twists in the wire. At least I think that's the theory anyway, for why they do that. So I'm just going to strip the outer silicone sheath, really nice, squishy, super flexible sheath on this cable, and then we've got the shield there, a little braided shield, which gives the cable additional strength. And I'm going to, I hope this is going to work. I just thought about this a few minutes ago. I'm going to take this toothpick and just separate, oops, well I broke the toothpick, that didn't work too well. use it to separate the braids of the shield here, because I'm actually hoping to use it to establish a common ground on the outside of the connectors. We'll get more into that process as we work on the project. So I'm just going to bring that up like that. That worked quite well, actually. Then I'll just pull this off to the side and give it a twist and gather it all up together, just like so. And then that's all out of the way. Now the next component of this cable is this fiber filling that it's got. So we can pull that apart. Some of it just rips out there. This gives the cable additional structure. The real part that gives it additional structure are these threads you see here. And they travel through the cable as well, giving it additional resistance to stretching and twisting. So all in all, this cable is going to be able to withstand, hopefully, the kind of punishment I put my USB cables through. So I'm just going to nip that all off, and then you're going to see where we run into the part where it's going to be a little complicated, because as you see, we've got white, white, and blue, blue. So there's no delineation between each of the conductors as 4 conductors. It just considers that there's 2 conductors, because that's how the microphone cable works. So what I'm going to have to do is we're going to start by very carefully stripping these. I need to actually apparently open my wire cutters open a little bit further here. This isn't actually the required tool for that job, but it'll get the job done. My fancy strippers here, they're preset stripping notches are not tight enough for these wires, so we're just going to have to carefully strip them manually. These are nice because you can block them off from closing up too tight, so you don't end up snipping off your wires. But you also, with practice, can sort of develop a feel for, as you squeeze, you can feel when the wire has been when the wire has not been severed, ideally, when the insulation has been severed but the wire has not. There's sort of a, you'll be applying pressure and you'll feel sort of a detent, and that's when you've cut through the insulation but have not managed to cut through the wire. This is actually some pretty resilient insulation on these conductors here. So I'm going to just carefully try to strip that off. Oh, come on, you. There we go. Oh, that's a bit messy, but it'll be good enough. Those really high quality copper conductors in this. This should be a lovely charge cable once I get it all built and ready. So we're just gonna, I think, give these a little bit more incentive to strip easier here. There we go, much better. So we're just gonna quickly twist these wires together here, just like so. And there we go. Now the next step is going to be to tin these wires. So I'm going to grab my solder here we're going to grab some flex paste. And I'm just going to dab a little bit of flex paste on these wires. Just a tiny bit. Doesn't take much. Oops, I put way too much on that wire. Good lord. There we go. And then we're going to uncoil my solder here. And we'll grab my grab my soldering iron here. This is that TS100 soldering iron that I reviewed a while back. That's temperature controlled. You can change the temperature digitally using these buttons here. And although it doesn't have as much thermal capacity as I like to see in an iron, given its size, you can't expect it to have too much thermal capacity. And so we're just going to quickly tin these wires. Ooh, they are just drinking that solder up. This is going to be a nice wire to work with, I think. So we'll just quickly solder those up. There we go. So those are now tinned. This soldering station there isn't actually meant to hold those, but or that particular soldering iron, but we'll make it do. So the next thing is I'm going to just go ahead and alternate this white, blue, white, blue. But we're going to start by talking about this connector. Now, each pin of a USB connector, as we can see, you look at this here, and we've got sort of a rectangle, and it comes in a little bit like so. Pardon my terrible drawing skills here. And then we've got some channels here. Oops. Let's try to, I have no eraser left, so we're just gonna pretend like I drew that a little bit more accurately there. And then it goes like that. And then it goes like that. So these pins in this orientation are numbered 1, 2, 3, 4. But when we're soldering it on, we have to flip it upside down. So now, that stupid pencil losing its pencil lid. Actually, I'm going to go to using one of these. So now that I've flipped it over, the pins are 4, 3, 2, 1. Now that shouldn't actually affect us too much, but we do have to keep that in mind sometimes when we're working with USB connectors. Now, those pins correspond. Pin 1 is your VCC, which is your 5 volts. Pin 2, that's a terrible 2. Pin 2 is your data plus pin. Pin 3 is your data minus pin. And pin 4, this is a bit of a contention between some people. Some people call it ground, some people call it minus. I like to call it V minus. That's a terrible V. Boy, I just cannot write today. Some people refer to it as ground. Both of those are technically correct. V minus is more electrically correct because the ground is actually the metal sheath on the outside of the connector. But for the purpose of this video, I'm going to refer to it as V minus. So I'm just going to dab a little bit of flux into the channels of the connector here, just like so. I don't want to put too much in there because it'll get really super sticky. I just want to get enough to just hold it all in. And then we're going to dab a little bit of solder into those channels, just like so. This is fairly tight soldering, so I'm hoping that you guys can actually see what all's going on here. Oh, I'm skipping a step. I should make sure that I do this as well. So I'm going to grab a little bit of heat shrink tubing here, and I'm just going to pre-place it over top of the wire here. And I think this is a little bit too tight. I wonder if I can bring it up from the other side. No, it's actually very, very tight. Let's see if I can get it on. Come on. Nope, that's too tight. So I'll just grab a hunk of the larger tubing here. Just like, I don't know, that much. That should be good. That's probably way too much, but this is actually really awesome heat shrink tubing. It's what they call dual layer heat shrink. And so you've got the outside plastic layer here that shrinks when you apply heat. And then on the inside there's actually an adhesive that melts under heat, of course. And when you heat shrink it onto something, that adhesive squishes down into everything and insulates and waterproofs, and just in general makes it a much nicer connection. So let's work on soldering this on. I don't know if you guys can hear my cat going ballistic in the background. Not too sure what's going on with her. She's doing her standard I'm going to go completely insane thing that cats do. Well, there we go. This is one of the more challenging soldering jobs I've ever had to do. It's very tight. I probably should have stripped off a little bit more of that cable in order to work with it, but lessons learned. We'll remember it for next time. There we go, there's that one. And then we'll bring the next blue one up. I almost singed my notepad there. That would have smelled interesting, I think. Come on. There's that one in. And one last wire here. I'm just going to jockey it over here. This isn't really meant for soldering onto flat connectors, I think. But there we go. So that's all nice and collected there. Now, I'm not really keeping track of... I don't like that. I want to try that again. Not really keeping track of which wires I'm putting on which pin here. Let's try to get that. There we go. That's much better. Oh, that's warm. Ow. Okay, so there's no purpose really to keeping track of which conductors you've applied where on this side of the circuit, because we can just use the continuity setting on our multimeter here to figure out where we want to plug the wires in later. So here we have the metallic sheath, which we're just going to kind of bend back there. And then we're going to grab this part, which comes in like so. Oops, which comes in like so. And tries to at least clamp down over top of this, but I'm noticing that the cable that I chose to use for this connector is quite a bit thicker than I think they were intending for anybody to use with this particular connector. But that's alright. We'll just have to squish it on nice and tight. I have to monkey around with it a little bit here to get it to settle in the way I want. I almost kind of want to fill that with a little bit of glue or something. I'm not particularly sanguine about how exposed those wires are, but I suppose they designed these with enough clearance. And it'll definitely have enough clearance because of the wire being held up and away by how thick it is. So I have to go grab a pair of... Oh, no, I have them right here, so I don't have to run away. These aren't, again, the ideal tool, but they'll do the trick. So I'm just going to kind of brute force this down like so. I should be using a crimping tool for this. I don't have a crimping tool. I can't afford a crimping tool at the moment because for some reason, it's another one of those capture market things, they are very expensive. So we're just going to kind of jockey that around, squish it in, and there we go. That's attached. And as you can see, I've got the outer sheath that the shield there is nice and tightly contained. I just have to squish this in a little bit more, I think. There we go. Now that's a USB connector. Now we're just going to bring this up and around the actual parts here. It's a very tight fit, but that's okay. Come on, get on. Bear with me a moment as I squeeze this ever so slightly too tight. Oops. Oh dear. Okay. Tell you what, I'm going to go to time lapse while I try to get this to cooperate with me, because I'm sure it's really boring watching me mess with it. So I'll be back in a few minutes. Okay, so I'm back. A lot sooner than I thought I was going to be because I caught myself in the middle of about to make a big mistake. So I realized that I shouldn't put this over top of it. Oops. I shouldn't put the connector completely together because I won't have access to these conductors in order to figure out which end needs to be soldered on to this part. So I'm glad I realized that I was getting ahead of myself there because that would have been a little embarrassing to mess that up. So our next step is to trim off this end and prepare it for installation onto one end of this. And I think the end I'll be using will be this end. So I'm just going to cut off, oh, I don't know. How much should I use? Let's just, I'm actually going to trim this one off fairly close to the origin here. So we're just going to knock that off there. And then we're going to spread these out and we'll strip them off as well. Just a little bit here. Like so. Looks like this is pre-tinned wire, which is interesting, but we're gonna still tin these just for the sake of being complete. Twist these nice and tight there. Now, I'm actually going to try to establish a color code for my conductors now using these. So the next step, I need to trim off a little ways into this. I'm gonna actually trim a little bit further back than I did before. I also just realized that I don't need to be trying to use the shield for a common ground, because there won't be any way to send the ground up through here. So that was a bit of a waste of time trying to preserve it previously, but oh well. Let's get a new toothpick here, because that idea actually worked quite well for stripping out the sheath here so we can get to the wires underneath. So we're just going to quickly peel the shield off like so. Just real quick, get it out of the way. Oops, a little shred of the outer insulation there, messing things up. Alright, so we're just going to finish opening that up. There we go. And being as I've discovered that I don't need to actually keep that part, we're just going to trim it off right at the level of the outer insulation here, just to get it out of the way, like so. And then we'll tear that out and peel these out, and we'll nip them off like so. My soldering iron just got bored and shut itself off. Fairly advanced programming on it. When it sees that it's not being used, it'll actually reduce its heat level from 300 degrees to 200 degrees, and it'll hold that for a while, and then if you continue not using it for a while, it'll get really bored and shut itself all the way off. That sort of saves energy. Whereas this one, my big soldering station here, if you leave it on, it will just stay on forever. I've actually had a couple of mornings where I've come in after working on a project or recording a video, and I've discovered that I left it on all night, which I always feel a little bit foolish and stupid for having done. But it happens to us all. So I'm just going to quickly twist these wires together, and then we're going to tin them up, and then we're going to do some continuity testing. So bear with me just a second here as we tin these wires, and dab a little flux on them, and then I'm going to grab my soldering iron and turn it on here. Wait for it to come to temperature, which in this case is 300 degrees. And there we go. And we'll just quickly tin these up, like so. Come on, cooperate. There we go. And one more. There we go. So now, stay in there. There we go. now we need to do some continuity testing to figure out which of these pins is which. I'm actually going to grab a variety of different color markers here to try to help me delineate which ones are which. So I'm just going to grab my multimeter here, and we're going to set it to the continuity mode, which is this little setting here that's got the diode and the speaker on it, and then we're going to hit mode, which sets it to continuity. Now the only thing that accomplishes is, oops, my leads are a little tangled here. Let's undo that. There we go. So the only thing that accomplishes is if you've basically got a super low resistance pathway, it beeps. So that's really good for just, I want to figure out which of these wires is which. Because I don't need to actually look at the meter, so I can actually pay attention to which wire I'm using. And that's interesting that I So this wire here, this white wire here, is wire 1. So just to help us remember, we're going to go 1 with my red pen there. So we know that, oh, and I should also mark the wire with some red too, so that we know that that's the red wire. So it'd be kind of silly to mark that the red wire was 1 without actually saying the red wire was 1. So once again, you'll see, as we showed earlier, that's the first wire there. So we'll bend that down out of the way. Hopefully it'll cooperate. And then we need to go find wire number 2. So it's not that one. So it would have to be, because I alternated them, if it's not the one blue wire, it'll be the other blue wire. So let's make the other, we'll make pin 2 magenta, or pink, or whatever color you choose to call that. I probably could have picked a better color to color blue. Okay, so that means that the uncolored white one is going to be 3. And we can actually go ahead and prove that by testing the continuity. And then the unused or unmarked blue wire is going to be number 4. So there we have that. Now, as far as how I want to delineate them on this, I think I will just, did I tin these yet? No, I did not tin this yet. I need to tin this. So I'm going to tin this really quickly. There we go. And it stands up rather nicely on its own because of the way the connector is built there. So let's just tin this up real quick. Ever so nostalgic smell of solder smoke. Don't worry, despite the fact that I use lead-bearing solder, there's no appreciable amount of lead in that smoke. That's mostly just the rosin core burning off. In the, this is rosin core solder, so it's actually got this stuff in the center of it as well. So we're just going to, I should plan ahead on the necessity of heat shrink here. So where was that little piece of heat shrink that I cut off earlier? I'm going to do a little trick here that will hopefully work for me, where you can spread heat shrink that's a little too tight open with a pair of pliers. I'm actually going to get a better pair of pliers. I'll be right back. Okay, I'm back. But it actually turns out that these aren't really any better for that purpose than the ones that I was using, except for the fact that they are purpose-built needle nose pliers rather than a multi-tool. So we'll just set that one off to the side here. We'll give this heat shrink just a little bit of a stretch, and then we'll go ahead and slip it over top of the wires here, which all of my marking on them is rubbing off. Oh, that's not good. So I'll have to go redo that in a moment, but that's okay. Let's get this back on. Actually, I tell you what, you guys probably have a good idea of what I'm going to be doing here, so I'm just going to go to time-lapse mode, and I'll be back in a minute once I've completed building this connector. So, see you in a few minutes. Okay, that took a little bit more effort than I was planning, because, one, I couldn't monkey it around quite well enough without help from my vise there. I also realized as I was getting ready to solder everything together that I had forgotten to put heat shrink to isolate each of the conductors, which was a bad thing to do. And you know what? These are still not really very well attached to each other, so be right back again. Okay, I fixed it. Now we get to continue with this process. So I realized as I was working on it that I needed to get some heat shrink to isolate each of those individual joints. So there was that. Let's see. Okay. So we'll test continuity on this one more time, just to make sure I got everything where I wanted it. But for now, I'm just going to grab this heat gun here, and sorry if I'm torturing any headphone users. I'm not too sure how this is going to affect the audio, but I'm just going to shrink this heat shrink nice and tight around the individual joints. I don't know if you can even hear me, so there's the heat shrink around each of those individual joints, keeping them nice and safe from shorting against each other. Now I'm going to take this slightly larger piece of heat shrink and bring it up to about here. I probably should have cut that one a little bit longer, but I'm probably over-engineering this just a little bit, but I prefer to have it a little bit overdone as opposed to not done enough. Because this is the part we want to actually last a reasonably long period of time. So I'm just going to overdo it a little bit and make sure that it's really thoroughly well built. So then we're just going to take the larger piece of heat shrink and shrink it down. Okay, so there's that all nice and shrunk down, and I can tell that the adhesive has been nice and squished down and into all of the joints, so it'll be nice and rigid once that adhesive cools. I'm just going to quickly test the continuity again to make sure that I got the wires where I wanted them. I'm hoping that it goes 1, 2, 3, 4 across this, and then 1, 2, 3, 4 across that. So I'm not too sure if, no, that's not going to work. Oh, because I have it on not the correct mode. There we go. That should fix that problem. Okay, so there's pin 1. There's pin 2. There's pin 3. And there's pin 4. So we've got the continuity working on that. And that is the first stage of the wire complete. And in fact, I can even close this up if I want. But I'll do that between videos. I'm going to leave this one for here. We will complete this project in the next video. So thanks everybody for watching. If you liked what you said, or if you liked what you saw, give me a comment or subscribe, ask me questions, share it with your friends, you know, do that thing you do when you like a video. And I will see you the next time. Bye.